What are the functions of the BIOS while the operating system is running? I always wondered whether the BIOS, apart from conducting post, starting the bootloader and passing control to the BIOS after one presses the power button, has any purpose or function while the operating system is running? Does the operating system communicate with the BIOS while running, and if so, how?
With modern OS, practically none. Linus Torvalds reportedly said its task is to just load the OS and get the hell out of there. Older operating systems like MS-DOS relied on the BIOS for many tasks, for example disk access, by calling interrupts. With modern OS, the bootloader quickly switches into 32 or 64-bit mode and executes the OS kernel. The kernel can register its own interrupt handlers, which can be called by user space applications. The kernel's routines can be more portable, since they don't depend on the specific hardware, more flexible. OS vendors can change them on demand rather than having to use whatever came with the hardware, more sophisticated. They can execute arbitrarily complex code rather than what was programmed into the BIOS, and more secure, since the OS can control access to shared resources and prevent programs from clobbering each other, implementing its own arbitrary permissions schemes. To interact with specific hardware, OS can load and use its own device drivers. So there's no need for the OS or applications to call most BIOS routines at all. In fact, for security reasons, BIOS interrupts are even disabled. Since the BIOS lives in 16-bit real mode, it's harder to call for modern OS. While use of the BIOS is very limited while the OS runs, its functions are still peripherally used. For example, when a computer sleeps, the OS is not running and it ultimately falls to the firmware to set the hardware to the correct state to pause and resume the OS. These uses are generally limited to API calls rather than calls to the full BIOS interface. API is a BIOS extension that brings power management under the control of the operating system, OSPM, as opposed to the previous BIOS central system, which relied on platform-specific firmware to determine power management and configuration policy. Note that officially BIOS refers to a particular firmware interface, but the term is commonly used to refer to computer firmware in general. Some recent computers, especially Apple I's, have replaced BIOS, sensu strictu, with UEFI, which of course then is what is called to implement these functions. For more information about how the role of the BIOS has diminished over time, see Wikipedia.
The BIOS provides a number of services to the operating systems, most of which are related to power management. Modifying the CPU and bus clocks, enabling/disabling mainboard devices, expansion port power control, suspend to disk and suspend to RAM, resume event settings. Suspend to disk is implemented in the OS most of the time as the OS can restore its state faster, only the kernel state is reloaded, and program state swapped in when required, which is significantly faster than reloading the entire RAM, but the feature remains in the specification. Suspend to RAM cannot be implemented by the OS, as it relies on the BIOS skipping the RAM initialization and test, so the OS needs an API to tell the BIOS that it intends to be resumed with the current RAM contents. In order to provide this service, the BIOS asks the OS to leave a certain RAM area intact. The interface for the OS for all BIOS services is a piece of virtual machine code that needs to be run on an emulator, and which generates the necessary I/O operations into the hardware. For suspend, this is generally implemented so that executing one of the hardware writes then triggers an interrupt, which transfers control to the BIOS.
There are three primary areas where an OS uses the BIOS in modern systems, such as those using the UEFI standard. The first is a series of services known as the UEFI runtime services. These services allow the OS to grab information that only the BIOS knows, such as the time that the BIOS was using, the boot order, the current user security profile, the information about the motherboard, DIMMs, etc. The second is System Management Mode, which is a hidden section of memory, SMRM, that is accessed by a High Priority Interrupt, SMM. Many BIOS use this to implement high-security OEM features or to implement hardware workarounds. The third is ACV. ACV provides configuration, power management, and hardware data and code used by the OS to augment what the OS drivers can find out using an industry standard or device driver. For example, is there a special signal to control the hard drive power, or is there a special way to talk to the battery that isn't covered by a standard? Tim.
Modern OS use the BIOS mainly for loading only, but there are still some uses for it which include, most notably, reacting to the power button, shut down the PC after 4 seconds. Included changing screen brightness settings on laptops, battery events on laptops, suspension.
If you want to support channel, please consider subscribing.